Good day, champions! Welcome to our Science 10 class. I am Sir Elcid, and we are live right now. So don't forget to join our Genio Forum so that we can have a meaningful discussion. You want to know our topic for today? Our topic for today is about the rate of reaction. It is also a part of our everyday chemistry series. Okay, so you already know about the reaction. Okay, what is a reaction, which we've discussed last topics. Okay, so our learning objectives are as follows. Okay, so performance standard is you will be able to use any form of media present chemical reactions involved in biological, industrial processes affecting life and the environment. Okay? Our learning competencies is to explain how the factors affecting rates of chemical reactions are applied in food preservation and material productions, control of fire, pollution, and corrosion. Okay? Our content standard, on the other hand, is that you should demonstrate an understanding of a chemical reactions associated with biological and industrial processes affecting life and the environment. Okay? So before we start our class, let's have an activity. Okay? So I call this activity, name this reaction. So I will present different types of reaction and then you will name that type of reaction. Okay? So more likely, the reaction that I will show are the ones which are happening in our everyday lives. Thus, it is a part of our everyday chemistry series, okay, of our unit 1. Okay? The first picture is this one. Okay? So I will now open our forums to see your answers. Okay? So kindly you can answer right now. Okay? So most of you got the correct answer. Okay? So the correct answer is corrosion or rusting of iron. Okay? So some answer corrosion, some answer rusting of iron. So it's both correct. Okay? They are both correct. Okay? So combustion, we all know iron reacts with oxygen and it produces rusts. Okay, so or iron oxide. Okay, next one. Next picture. Okay, so next picture, which type of reaction is this one? You can name it in its common terms. Okay, so many answered. Okay, so many answered food spoilage. Some fruit spoilage, okay, it's the same thing. Decomposition of organic materials, okay, so more likely decomposition, okay, so very technical, right? So the answer is food or fruit spoilage and also the decomposition of organic materials, since it is organic. Okay, our next picture is this one, okay? So this one is which type of reaction or what do you name this reaction? Okay, others said fire. Okay, so it's okay. So I got this one. Some answered combustion of wood, some answered combustion of fuel, and some. Okay, so the same thing. Okay, so I will reveal the answer right now. So the answer is. Oh, where's the answer? Sorry. Okay, so combustion of fuel. So wood is also considered a fuel, right? Because it burns or it combusts, or a carbon dioxide production, since fire or combustion produces carbon dioxide, which is our main source of pollution. Okay. Next or last question is this one. Okay, it's very easy, right? We've tackled it in our organic chemistry. Okay, so this one is, okay, everyone got the correct answer. This is called the fermentation of alcohol. Okay, so very good. So let's compare two pictures. Okay, let's compare two pictures from this set of pictures that we have. Okay, this one, rusting of iron. Let's compare it to food spoilage. Again, we'll compare rusting of iron, and food spoilage. Okay, so my first question is, do you think these two reactions are happening at the same rate? Okay, so I'll check the forum right now. Okay, so Alex said no, sir. Okay, so if no, which one is faster? Corrosion or decomposition of food or food spoilage. Okay? Okay, so we have an answer here. Anna said the spoilage. Okay, so her answer is the food spoilage. Okay? Since it can happen overnight to a week. Okay? She justified it. It can happen from overnight to a week. And rusting or corrosion can happen from months to even years. Okay? So, that's very good, Anna. Okay? But why does some food spoilage happen overnight while some happens for a week? Also, some corrosion happens faster than the others. Why is that? Okay? You can answer that right now. Okay, so Ben said, we have an answer right now. Ben said, it depends on the food and the type of iron as well as the surroundings or their surroundings. Okay? So, very good. It depends. There are many factors affecting, which is our topic for today, right? And which is the, in our competency. That's our focus, okay? So, it depends. The rate of the reaction also depends on many factors, right? That's why some food, okay, spoiled overnight and some food are spoiled every week or the next week. Okay, so it depends. Okay, so now we will have a trip inside the matter. And I mean in a molecular level. So now we have a statement, okay, the preliminary statement that every reaction happens in different rates. Some are very slow, some are very fast. And for us to understand it even more, or to elaborate our understanding about it, let's look at it at the molecular level. So later, we will use a PET interactive simulation or PHET interactive simulation created by the University of Colorado. Okay? So, but before that, let me give you some brief background to have prior understanding before we start our activity. Okay? So, let's deal with some definitions. Okay? So, as we all talked about, the rate of reaction is defined by how fast the chemical reaction takes place. So, just like I said, some are very slow, some are very fast. Okay, so the rate of reaction is defined, defined by how fast the reaction takes place. Or in other words, how fast the reactant diminishes or how fast the products are being produced. Okay? So, I believe it's very clear for all of us. The next one is another concepts. Okay? So, chemical reactions. Okay? Chemical reactions happen when the molecules of both reactants collide and its atoms rearrange. We call it a fruitful collision. So, we will discuss that. We will elaborate that, okay, using the PET simulation. Okay, so there are molecules. We all know that each substances, okay, have, or each compounds or each substances have different molecules or atoms, right? For them to have a reaction with one another, their molecules must collide, okay, with each other and rearrange. Okay, that's why in our last topic, chemical reaction happens only when atoms are rearranged. Okay, so that's the reason why the molecules collide with each other and then a reaction happens as the atoms rearrange. Okay? So we call that, if the collision result into the rearrangement of atoms, the collision is, we call that collision as fruitful collision. And they are only fruitful in some circumstances, which we will talk about. Okay, so I will demonstrate these conditions to you using the simulator. Okay, so right now I will change into our simulation so that you can have a better understanding. Okay, so right now we will use the PhET, the interactive simulation by PhET from the Colorado University. Okay, so our first situation is this one. So our reaction is A, the atom, plus a compound with a B and C. Okay, they are bonded with each other. Okay, so I will let them collide. Observe, just observe right now. Okay, so what do you think happened? Okay, do you think a fruitful collision happened? Okay, so all of you said yes. Okay, so what is your evidence to support your claim? Okay, I'm looking at our forum right now. Okay, so Nicole said the atoms in the molecule were rearranged or they changed partners. Okay, so that's a very good observation, Nicole. Okay, let's find out more. Okay, so let's go with our second scenarios. Okay, so I will reset all again, all settings. Okay, so our next scenario, or the second scenario, is this one. Okay, observe well. Okay, so what do you think happened? Okay, did a fruitful collision happen? Okay, so all of you said no. Okay, very good. Okay, so if all of you said no, what is your evidence to support your claim? Okay, so Sarah said the atoms in the molecules were not rearranged. Okay, very good. Okay, so very good. So on the first condition, the atoms were rearranged. So that means a fruitful collision happened. So if this one, there's no rearrangement of atoms, so therefore there is no fruitful collision. Okay, so what can be our finding? Okay, what must be the reason why it happened? Okay, so what do you think? Why do you think in those two conditions, what is the reason of that? Okay, so John said there's not enough momentum or energy unlike the first condition. Okay, very good. Okay, so it depends on the energy. Okay, so what can be our findings about it? Okay, so Isabel said there must be sufficient energy for a fruitful collision to happen. Very good. Okay, so very good. We call it the activation energy. Okay, as you can see in the lower right diagram of, okay, so as you can see in the lower right diagram, I'm showing it right now, of the simulation, activation energy must be reached. Okay, so the activation energy is this one. Okay, at the peak. Okay, so it must be reached for the collision to happen. Okay, so in summary, let's summarize what we have learned from our simulator. Okay, there are two conditions which can make a fruitful collision to happen. Okay, the condition number one, there must be sufficient energy for a fruitful collision to happen, as we've already discussed. Okay, we call it the activation energy. Activation energy must be reached for a fruitful collision and thus for a reaction to happen. Okay, the condition number two must be, okay, in order for a fruitful collision to happen, the reactants must be in correct orientation. Okay, now for our activity, pause this video as you answer the activity sheet on your notes. Okay, so if you pause it right now, and I will, this is our activity sheet. Okay, so I will explain it. Okay, so the first one is it will produce effective collision or fruitful collision. Number two, it will not produce fruitful collision. Okay, so pause pause the video. Okay, okay, and then answer the question. Okay, so now that you pose the question, this is the answer. Okay, A is the hydrogen and B is the iodine. Okay, and then they will be oriented, they will be parallel with each other, and then they will collide so that they can form an hydrogen, 2 moles of hydrogen iodide gas. Okay, in orientation number 2, this will have no reaction since only A and B will only one pair of A and B will collide with each other. Thus, there will be no reaction. Okay? So, the bond with A to A, and B to B, or hydrogen to hydrogen, iodine to iodine, will hold them together. Okay? As they collide with each other. Okay? So, right now that you've learned about it, guys, okay, so as you answer that to your notes, do you get the correct answer? Okay, so let's see our forum. Okay, so right now, many of you get the correct answer. Okay? Now, let's talk about how these principles explain how different reactions happen at different rate or span. As you said earlier, there are different factors affecting reaction rates. Okay, so the following are 4 main factors affecting the rate of reaction, which we will discuss. Okay, these are temperature, surface area of contact, the presence of catalyst, and the concentration. So right now, I have a question for you. Okay, how to prevent this from happening? So we all know that this is a food spoilage or decomposition of okay, so this is a decomposition of organic materials. Okay, if I will ask how will I slow down the rate of reaction of food spoilage, what will be the first thing that comes into your mind? Okay, so Ray answered, put it on a fridge or freeze it. Or Mike said, lower the temperature. Okay, so yes, we usually place the food in an area with a low temperature to postpone its spoilage. Okay, so that we can eat it when we want to eat it. Right? Okay? It delays the spoilage and keeps food safe by preventing microorganisms from growing and by slowing down the enzyme activity that causes food to spoil. Okay? Okay, so right now we found out that the lower the temperature, the lower the rate of reaction. And also, the higher the temperature, the higher the rate of reaction. Okay? That's why when we freeze a fruit or a food, okay, the spoilage are postponed or the spoilage happens very slowly. Okay? Because the molecules or the enzymes and the microorganisms moves very slowly, and that the decomposition happens very slow. Okay? If you increase the temperature, like in cooking, okay, more molecules will move fast, more fruitful, more energy, and thus more fruitful collision, and the faster the rate of reaction. Okay? So, next factor is the surface area, okay, or the surface area of contact. As we can see, fruitful collisions happen when there are contacts in between reactants. Okay? In combustion, oxygen and fuel reacts when they are in contact with each other. Okay? So, what could be one of the ways to stop the combustion? Okay? Okay, so, okay, you can answer right now in our forum. Okay, K said by limiting or hindering the contact between oxygen and fuel. Okay, so excellent. That's what fire extinguishers do. Okay, so most fire extinguishers soak up heat, melt on the fuel, and cut off oxygen, but they also neutralize the fuel, cutting it off from the fire. So the primary purpose of fire extinguisher is to separate or to eliminate or decrease and then fully eliminate the contact between the reactants, which are oxygen and the fuel. Okay? So, thus, we can say that the larger the surface area of contact means the higher the rate of reaction. Whereas the smaller the surface area of contact, the lower the rate of reaction. And if there's no contact between the reactants, therefore, there is no reaction. Okay, now let's move to the third part. Okay, let's talk about how catalyst affects the rate of reaction. Okay, a catalyst speeds up the rate of reaction by lowering the activation energy needed for fruitful collision. Okay, it happens due to a certain property of a catalyst. So as you can see in our diagram, okay, the activation energy without catalyst is very high. Okay, so it needs more energy for it to react faster. Okay, while the catalyst, in the presence of catalyst, the activation energy with catalyst is lower or considerably lower, so that more reaction can happen even at a small amount of energy. Okay, so catalyst speeds up reaction. Okay, so this one. Okay, so one of the example is also a salt water. Okay, salt water in an iron. Okay, salt water does not make a metal rust, but it accelerates the rusting process, because electrons move easily in salt water than they do in pure water. Very interesting. Okay, another one is the yeast in the fermentation. Okay, fermentation has been used for centuries to produce alcoholic drinks. Okay, this process, enzymes in yeast catalyze the breakdown of sugar molecules into ethanol. So if there is very little yeast, okay, or very few yeast, okay, the reaction rate is very low. So the presence of catalyst, okay, the more catalyst, it increases the rate of reaction. Okay, so as we can see here right now, okay, so the presence of catalyst causes higher rate of reaction. Okay, so right now I now have a question. I have another question for you guys. Okay, so which one do you think will have a higher rate of reaction? Okay, so in that two situation, okay, in our simulator, okay, so which one, the right side or the left side? Okay, so Jessica said the left one. Okay, so why do you think so? Okay, so Jessica, why do you think so, Jessica? Okay, so Jessica replied, because there will be more chances of fruitful collision to happen. Okay, so the more substances or the more molecules means the more collision that will happen, the more the chance the fruitful collision will take place, and thus the faster the reaction. Okay, so and thus higher rate of reaction. Okay, so that's very good. The more fruitful collision, the faster the rate of reaction will be. Okay, so the higher the concentration, the higher the rate of reaction, which will yield more products at a certain amount of time. Okay, the lower the concentration, the lower the rate of reaction. Just like in fermentation, okay, we use grapes and barleys and other grains, okay, because they have more sugar content. Okay, the more glucose, the more yeast will process in fermentation, and then the more product we will have, which indicates that the faster rate of reaction is happening. Okay? So right now, let's have a home activity. Okay? Okay, so to further understand the lesson, let us have an activity. Do these two home activities and determine the factor affecting the rate of reaction and give a brief explanation about it. Just write it on your notebook. Okay, pause the video. Okay, pause the video and do these things. Okay, pour a coffee powder in 2 empty cups. Pour cold water in the first cup and hot water in the next one. Okay, and stir and observe. Okay, the second activity is to pour hot water into empty cups, 2 empty cups. Pour crushed pepper in the first cup and the whole pepper in the next one. Okay, stir, taste, and observe. Okay, so right now, pause the video and you do the activity and do it on your notes. Okay? Okay, so I believe you have learned so much right now. So it's time to evaluate. Okay, guys? So let's evaluate if you were able to learn something. I have a 6-item quiz right here. Okay, so write T if statement is true and F is the statement is false. Okay, so write your answer on your notebook. Okay, pause this video and write your answer. Okay, so I will reveal the answer later. Okay. Okay, so now that you've answered, let's check. Okay. Okay, the answer keys are... Okay, so this is also the evaluation sheet. If you want the worksheet or you don't have an internet connection, you can answer that. Okay, so the answer keys are FT, FT, FT. Okay, so that's the our answer. Okay, so for your assignment, guys, wait, let's fit it to our learning management system, Genyo. Okay, so create an essay with a maximum of 150 words entitled "A World Where All Reactions Have the Same Rate," and pass it in the assignment section of our lesson package in Genyo. So you will describe a world where all reactions like combustion, explosion, rusting, all have the same rate. Okay, so we'll picture out and embed it in an essay form. Okay, so last one for our ending before we end, guys. Okay, so let's ponder our values integration. Okay, I leave you the verse Ecclesiastes 3:1 of our GNT version. Everything that happens in this world happens at the time God chooses. Okay, so if we will process it, if chemical reactions have different rates, people's lives have different time zones. When I mean time zones, most people become successful or start a business when they are old, and some people are starts when they are young, but they get broke when they are old. Okay, so don't compare yourself to others because you have the different time zone than them. Maybe you think you are not successful right now, you are still waiting, but maybe it's not your time yet. Okay, everything has time and God chooses the timing. Okay, that's why we have that's why chemical reactions have different rates, because everything in this world happens as time God chooses. Okay, and you will know the importance of it when you do the assignment. Okay, the world when all rates, okay, all chemical reactions have the same rate. Okay, so these are my resources, and thank you very much, guys, for our... Okay, thank you very much, guys, for listening. Don't forget to do the activities for our classes and prepare for our next topic. You just read ahead, and thank you very much. Good luck, guys, and may God bless us all.